On June the 23rd, 2026, a signal left a small, aging spacecraft that hadn't spoken a word in almost a year. It began its journey home at the speed of light, but even at that speed, it would take nearly 9 hours to arrive. 9 hours for a message to cross a gap so vast that sunlight itself takes over 8 hours just to reach the spot where this machine now drifts. By the time that signal reached a quiet control room in Laurel, Maryland, the spacecraft that sent it was already almost 6 billion miles further away than it had been when the message departed. This is the story of New Horizons, humanity's most distant active explorer of a single world, a machine that fell silent on purpose and then, against every reasonable expectation of what a 20-year-old piece of hardware should be able to do at the edge of the solar system, woke up in perfect health. To understand why this moment matters, you have to go back 2 decades, to a cold January morning in 2006, when a rocket lifted off the coast of Florida, carrying a spacecraft roughly the size of a grand piano. It left Earth faster than anything humans had ever launched before, fast enough that within 9 hours it crossed the orbit of the moon, a trip that took the Apollo astronauts 3 days. That speed was not for show. New Horizons had a single audacious destination: Pluto, a world so distant and so poorly understood at the time that even the best telescopes on Earth could only make out a fuzzy, pixelated blur. For 9.5 years, the spacecraft crossed the solar system, sliding past Jupiter for a gravitational slingshot in 2007, and then continuing on, alone, through the cold and the dark, toward a planet nobody had ever seen up close. Then, in July of 2015, it happened. New Horizons swept past Pluto and its largest moon, Charon, at over 30,000 miles an hour, capturing images that rewrote what scientists thought they knew about small, icy worlds. Pluto turned out to be alive, not with life, but with geology. Nitrogen glaciers flowed across a heart-shaped plain. Mountains of water ice, hard as rock at those temperatures, jutted into a hazy blue atmosphere layered like a wedding cake. Nobody had predicted any of it. The mission that was supposed to answer questions about a distant dot in the sky instead opened up 100 new ones. But Pluto was never meant to be the end of the story. New Horizons kept going deeper into the Kuiper Belt, a vast ring of icy debris left over from the solar system's formation, stretching billions of miles beyond Neptune. In 2019, on New Year's Day, the spacecraft did something no human-made object had ever done. It flew past a small, two-lobed world called Arakoth, the most distant object ever explored up close, a frozen relic that had barely changed since the solar system was born. And still, New Horizons kept going. By October of 2024, it had traveled 60 times farther from the Sun than the Earth is, twice as far as it had been during the historic Pluto encounter almost a decade earlier. Out there, sunlight is so faint it's barely brighter than a distant street lamp. Temperatures hover near the theoretical cold of empty space itself. And the spacecraft's power source, a chunk of decaying plutonium that has been quietly generating electricity since before it ever reached Pluto, grows weaker every single year. This is the part of the story most people never think about. A spacecraft flying through interstellar darkness doesn't get to plug in and recharge. It runs on a radioisotope thermoelectric generator, a device that converts the heat of natural radioactive decay into electricity. And like any radioactive material, the heat source is slowly, irreversibly fading. Every year, New Horizons has less power available than the year before. Every year, the mission team, back on Earth, has to make harder choices about which instruments can stay on and for how long. So last August, the 7th day of the month in 2025, the mission team made a decision that might sound counterintuitive. They put the spacecraft to sleep, not because anything was wrong, quite the opposite. Hibernation is a deliberate, carefully engineered survival strategy. When New Horizons enters this low-power state, most of its systems power down. The instruments stop actively observing. The onboard computer stops waiting for new instructions. Only the most essential systems keep running, monitoring the spacecraft's health, conserving the dwindling power for the journey still ahead. It's the deep space equivalent of a ship's crew sealing themselves below deck during a long, harsh winter, trusting that the hull will hold and that spring, eventually, will come. For 321 days, that is exactly what New Horizons did. The longest hibernation period in its entire 20-year mission. Longer than any previous rest, at a point in its journey farther from the Sun and farther from any hope of quick rescue than ever before. And here's what should make you pause. This wasn't a spacecraft resting comfortably in a well-understood part of space. This was a spacecraft asleep in a region so remote that only 2 other human-made objects have ever traveled through it. The twin Voyager probes, launched almost 30 years before New Horizons itself. If something had gone wrong during those 321 days, there would have been no way to know until it was far too late to fix. But something extraordinary happened instead. Once a week, all through that long silence, New Horizons sent back a single simple signal. Not data, not images, just a status beacon, a heartbeat crossing billions of miles to say, essentially, I'm still here. And week after week, for nearly a full year, that heartbeat came back green. Not once did it waver. Then, on June the 23rd of this year, the moment the mission team had been waiting for finally arrived. Acting on commands that had been carefully calculated and uploaded to its computer nearly a year earlier, because there is no possibility of real-time control at this distance, every instruction has to be planned days or weeks in advance. New Horizons executed its wake-up sequence. It began, slowly and deliberately, bringing its systems back online, exactly as programmed, exactly on schedule, despite everything it had endured getting there. Back on Earth, at the Johns Hopkins Applied Physics Laboratory, flight controllers Mark Lahr and Josh Albers sat beside Mission Operations Manager Alice Bowman, watching data stream in from a machine that was, at that exact moment, roughly 5.9 billion miles away, 9.5 billion kilometers, a distance so large that the numbers themselves start to lose meaning. To put it another way, light from the sun takes about 8 minutes to reach Earth. It takes New Horizons' radio signal almost 9 hours to make the same one-way trip home. When Bowman's team finally saw confirmation that the spacecraft had woken successfully, they weren't watching something happen live. They were watching the echo of an event that had technically already finished nearly 9 hours earlier, in the freezing dark beyond the edge of the solar system's known worlds. And the news, when it came through, was almost disappointingly, wonderfully simple. New Horizons was fine. Better than fine. In Alice Bowman's own words, every single status report sent during that entire year-long hibernation had come back green. Nothing had failed. Nothing had drifted off course. A 20-year-old spacecraft, running on a power source that had been quietly decaying since before it ever reached Pluto, had drifted through the emptiest, coldest, most unforgiving region humans had ever sent a machine into, and had come out the other side in what NASA itself described as good health. So what happens now? This is where the story gets even more interesting, because New Horizons didn't wake up just to check in and go back to sleep. It woke up carrying nearly a year's worth of stored scientific data, collected quietly by its instruments, even while the spacecraft itself was resting. Engineers are now beginning the careful process of downlinking that information, starting first with basic health and safety telemetry, and then moving on to the actual science. Measurements from instruments with names that sound almost mundane until you understand what they're actually doing out there. The solar wind at Pluto instrument and the Pluto Energetic Particle Spectrometer have been continuously sampling the charged particles streaming outward from the sun, tracking how that solar wind changes as it thins out toward the edge of the solar system's influence. The Venetia Burney Student Dust Counter, named for the 11-year-old English schoolgirl who, in 1930, suggested the name Pluto for the newly discovered world, has been quietly counting the microscopic impacts of interstellar dust grains, particles that may have drifted into our solar system from entirely different star systems. And in about 3 weeks from its wake-up, New Horizons is scheduled to turn on one more instrument, an ultraviolet spectrograph called ALICE, which will begin studying the distribution of hydrogen gas in what's known as the outer heliosphere. If that phrase sounds abstract, here's why it actually matters enormously. The heliosphere is essentially a vast, invisible bubble carved out by the solar wind, a bubble that surrounds our entire solar system and shields it from the harsher radiation of interstellar space. Somewhere out at its edge lies something called the termination shock, the region where the solar wind, which has been rushing outward from the sun at hundreds of miles per second, finally slows down dramatically as it collides with the thin soup of particles that fills the space between stars. Only 2 spacecraft in all of human history have ever crossed that boundary and lived to tell us about it. Voyager 1 and Voyager 2, both of which are now traveling in true interstellar space, more than 140 astronomical units from the sun. New Horizons isn't there yet, but it's heading in that direction, and unlike the Voyager probes, which were designed in the 1970s with the instruments available at the time, New Horizons carries more sensitive, more modern instrumentation. According to Pontus Brandt, the mission's project scientist at the Applied Physics Laboratory, the data New Horizons eventually gathers near that boundary could become what he called a genuine treasure trove for space physicists, trying to understand exactly how this enormous, largely invisible barrier actually works. It's a rare chance to double-check and refine what the Voyager missions taught us decades ago, using instruments built with 40 more years of engineering progress behind them. Of course, none of this comes without cost. The spacecraft is currently speeding away from Earth at roughly 300 million miles every year, and its radioisotope power source keeps fading with every passing month, whether the spacecraft is awake or asleep. The mission team has already updated New Horizons' onboard autonomy software to account for this. New logic designed specifically to help the spacecraft cope with less available power and with radio delays that will only continue to grow as it drifts farther and farther from home. Ground-based software is being upgraded too, in parallel, to make it easier for a shrinking team of engineers to keep operating a spacecraft that, every single year, gets a little harder to talk to and a little more expensive in terms of scarce power to keep running. There's something almost poetic in all of this. New Horizons was built to answer one question: what does Pluto actually look like up close? And it answered that question so thoroughly, so beautifully, that NASA simply kept it going, kept sending it deeper into a region of space that had barely been mapped except by two much older siblings launched a generation earlier. And now, 20 years after launch, with a power source that has been quietly dying since the day it left Earth, this small, aging spacecraft has once again done exactly what it was asked to do: survive the dark, wake on schedule, and keep reaching for the edge of everything we know. Nobody can say for certain how many more times New Horizons will be able to wake up like this. Each hibernation cycle asks a little more of hardware that was never designed to last this long in a place this far from any possibility of repair. But for now, in the summer of 2026, humanity's most successful planetary explorer beyond Neptune is awake, healthy, and listening, somewhere out past Pluto, past Arakoth, past almost everything we've ever mapped. A spacecraft the size of a piano is quietly beginning to speak to us again. And we are, once more, about to learn something about the edge of our own solar system that no one has ever known before.